In this session, I'm going to discuss about the internal representation of a variable in Python and also the notion of constant in Python. In Python, variables are quite different from variables in C or C++. Actually, Python doesn't have any variable. Rather, we can say that it has a tag or names. First of all, let's understand the working of variable in C. Then we will be able to differentiate the Python variable from it. In case of C or C++, we need to first define the variable type, based on which some space in memory will be reserved. And within that space, the value that is 10 will be stored. And the variable name a will be mapped with that memory location. Now, if you try to change the value that is from a is equal to 10 to a is equal to 20, then the value that is stored in memory location 2016 will also be changed from 10 to 20. But if you try to declare the new variable with same value, that is b is equal to 10, then again a new memory location will be reserved for that, and 10 will be stored in that location, and also b will be mapped with that memory location. Now let me demonstrate it practically. So this is a C program. For now, just ignore this part and just focus on these lines. In the first line, I have declared an integer variable, that is a is equal to 10, and then this line will print the value of a, and this line is responsible for printing the memory location of a, and then I have changed the value of a from 10 to 20, and then again I am trying to print the updated value of a and the memory location of a. Now let me run this code. Now note that initially the value of a is 10 and the memory location is 65FE1C. After changing the value has got updated, that is 20, from 10 to 20, but the memory location still remains same. Now let's see what happens if we declare a new variable with same value, that is b equals to, let me define a new variable, that is b equals to 10, and then if I print the value of b and the memory and also the memory location of b. Now note that the memory location of a is 65FE1C, but the memory location of b is 65FE18, that is different. So in this case, a new memory location is created for the new variable. Now we can conclude that in C or C++, if we change the value of existing variable, then it will not going to create a new memory location. But if we create a completely new variable, then it will assign a new memory address for that variable. In case of Python, the picture is quite different. Actually, Python doesn't have any variables. It has names, that is a reference to an object. After assigning the name a to the object, CPython interpreter, that is the standard Python interpreter written in C, will create a Pyobject. Now you may ask, what is a Pyobject? Actually, the CPython interpreter translates all the objects in Pyobject at runtime, which has basically three fields, that are type, value, and reference count. After declaring the variable, the type field is going to set integer, the value field 10, and the reference count will set to 1. And the name a is going to point the Pyobject in memory. Now if I try to declare a new variable with same value, then Python will not going to create a new Pyobject. Rather, the new name will also point the same Pyobject, as the value is same in both variables. Only the reference count will get increased by 1. Now if I try to change the value of x, then Python is going to create a whole new object. Unlike C or C++, it will not going to change within the same memory location. It will create a new Pyobject because of immutable nature. We will see this mutable and immutable topic in our upcoming lecture. The tag a will now point to the new Pyobject, and the reference count of the previous Pyobject will become 0, and it will be deleted by the garbage collector. Here I have declared an integer variable, that is x is equal to 10, and then this line will print the memory location of x. This id is an inbuilt function that is used to print the memory location, and then I have changed this value of x from 10 to 12, and then again I am trying to print the memory location. Now if I run this code, now note that the memory locations are different, okay, but we have seen that in case of C language, if we try to change the value, it will not going to create a new memory location. Rather, it will change the value of existing location. Here I have created multiple variables with same value. In this case, Python is not going to create different Pyobjects for each of the variables. Rather, these tags a, b, c, and d are going to point the same Pyobject in memory, and the reference count field of that Pyobject will be 4. Now let me run this program. Note that the memory addresses are same for each of the variables. So this is all for this video. In our next video, we will learn about the notion of constant in Python.